Hello Internet, my name is Quinn and this is Blondihacks. This is part 2 of my feed water pump build, and this includes a collaboration with the incredible sheet metal fabricator Ron Covell, link to his channel below. Ron is going to make a water tank for this feed water pump. You of course need somewhere to pump the water from when you're pumping it into the boiler, and Ron agreed to help me out with that, and I'll include some clips of how he made this tank, and be sure to check out the link to the full video below. It's a really incredible piece of work, and you really want to see how a master makes this type of thing. All right, let's get going on this pump. Here's where I left off last time. We just did that tricky internal thread there. Now I need the matching thread for the packing nut that goes in that thread. So I've got the stock here that came with the kit for this purpose, and I'm going to prep it for cutting that external thread. Make sure I've got enough sticking out here to part off the final part, and I'll face off the end as is tradition, and then I'll turn down the body to the major diameter of the thread. And people have been asking me about this tool holder a lot lately. This is a tangential or diamond tool holder. It's actually a very old school idea that hobbyists have kind of rediscovered lately. And this one is made by Eccentric Engineering in Australia, so go check out his shop if you'd like to know more. It's a really great tool. I really enjoy it. Next I turn down the end a little further. That's going to form the O-ring seat, which is going to seal this packing nut around the piston bore of the pump. And then I also turn down a similar area at the base here, which is just a thread relief. I'm making it to the drawing, which calls for quite a wide groove here. I don't think this is strictly necessary that it be this wide, but as I said, I'm just following the drawing here. If you happen to notice that a lot of the feeding in this section happen to be a little hurdy-gurdy, that's because I'm feeding it all by hand. That's because I've still got the threading gears in the lathe from when I cut that 18 TPI internal thread. I knew I was going to have to single point this one as well, so there was no point in taking those gears out. So I did my scratch pass just to be safe, but once again I know it's going to be okay because I just cut the mating thread with the same gears. I don't have a 9/16 die, nor do I have a die wrench large enough for holding a 1.5 inch die, which will be required here, so single pointing it is. If you watched the first video in this series, then you know that my strategy here was to cut the internal thread first because it's easier to cut an external thread to match it than the other way around, and it doesn't matter that these threads be precisely cut to some machinery handbook standard because they're not interchanging parts with anything else. These two parts just have to fit each other. So my strategy is to just cut this external thread to match the one that I just did. At least, that was the theory. Cutting an external thread like this in a piece of brass is the easiest possible form of thread cutting that you can do, but my strategy kind of fell apart when I realized that I couldn't really test fit it on the part because the foot on the casting there doesn't give me enough room to do so. I was able to thread it on just far enough to know that it's definitely not too large. In fact, I think I cut that thread a little bit deep, but we'll find out when the part is done. The center bore here gets center drilled and reamed out to size for the piston rod that passes through it. And now I can find the edge there of that shoulder with my parting blade, translate over to the thickness of the head that I want on this nut, and part it off. And of course, while I'm in there, I'm going to throw a bunch of chamfers on everything because chamfers are what separate us from the animals. Yahtzee! Okay, moment of truth. Let's thread this thing in there. And while it certainly threads in very nicely, that thread is quite a bit looser than I had in mind. So my strategy of making the internal thread first because of how easy it is to fit an external thread, well, it didn't work so good because I wasn't really able to test fit the part while I went, which was the whole plan. Now, I think that's still going to be fine. The tightness of that thread doesn't actually matter very much. So I'm going to try it, and if it doesn't work, then I'll remake this part. But actually a loose thread here might actually help because it's going to give the piston bore the ability to align itself with the rest of the fittings. Over to the mill now to do the features on the ends of the pump casting there. I'm setting it up with a V-block there, just holding that center boss there. And I need to get it straight in this orientation. So I've got the feet there to indicate on, but it's a very short distance. So I'm using my tense indicator there, my highest resolution indicator, because when you've got such a short distance to indicate over, any error that might be there is much more difficult to detect. Then to get it vertical, I'm comparing the lower foot to the upper foot. So I just check the reading on one foot, then move down without touching any axis except Z, and check the other foot, and then tap it back and forth until both feet read the same. Those 2 feet were machined in the same setup, so I know that they are in the same plane. And I've got it to within a couple of tenths here over a few inches, so I think that's certainly good enough for drilling these short little holes that I'm about to do. Now to line up on these bosses, I'm using the old trick of a gauge pin or other piece of stock that's the same diameter as the boss to center up on that. And in principle, these 2 bosses should be on the same Y value here. I just need to determine what the X spacing of them is. So I checked the other one as well, and I did find that the other one was off a little bit on Y, about 5 thousandths. And you could leave that alone if it was important that the 2 bosses be aligned, but it's actually not, so I opted to shift it a little bit and make them both look good. It's more important that the plumbing fittings look good on their respective bosses, I think, than them being perfectly in line with each other. That little bit of error could be in my setup, or it might be in the casting, who knows. Next I machine those flat, and now I can set up to drill. I decided to put a little machinist jack under the far end of the casting here. The drilling that's going to happen here is kind of hanging out in space, and it is possible that the downward force could cause the casting to get a little crooked in the vise there. So a little bit of extra insurance. Probably not necessary because these are tiny drills and the forces are low, but you know, better to have it and not need it. And I'm going back and forth between these 2 bosses with each operation because they're both the same. And what I've done is I've got the center of one of the bosses in the absolute origin and the other one in the incremental origin on the DRO, so I can easily go back and forth between them, and that allows me to compensate for that little 5 thou error between the 2 castings as well. Finally, both these get tapped for plumbing fittings. The thread here is fairly arbitrary. I've chosen 1/4 to start with. Basically, you drill and tap these to whatever size you want for whatever types of plumbing fittings you're going to be using. Typical choices here for model engineering would be like 1/16 NPT, or in my case, I prefer to use straight threads. They're just easier to cut, and tapered threads on model engineering components really aren't necessary if you just use a little Loctite 545 on them. I find that a lot easier than messing with tapered threads. Got one more operation on this base casting here. For that, I'm going to need to set it up sideways, which is easy to do because I've got those parallel clamping surfaces between the feet and the top of the valve body there. And I'm just tapping it in straight, once again, using the edge of that foot webbing there, which has kind of been my go-to reference when I don't have anything else on an axis on this casting. And it's been working fine. It's not super critical for this hole that it be perfectly straight, but, you know, good practice is never a bad idea. Then once again, I line up on that boss with a gauge pin the correct size to get it aesthetically centered there. The exact location of this hole isn't very important. We're just trying to make it look nice. And then I start with a long center drill to get around the foot on the casting there. Just need a little bit of a dimple there to get the drill to go where I want it to. And then I just drill this through. This is the hinge pin for the pump handle. The next part to make is the piston for the pump. The kit comes with a piece of precision ground 01 tool steel for this purpose. It's already cut to length and chamfered, so that saves us a lot of work. So I'm centering up on it with the edge finder and finding the end, and we need to cross drill it for a hinge pin here. So far this is very straightforward. Now things get a little more interesting. We need a slot that's exactly perpendicular to this hinge pin hole. That's why I have it set up in the collet block here. So I can rotate it 90 degrees and then line it up with the front edge of the fixed jaw again. And now I'm right back where we were. I don't have to edge find anything, and I can translate to the start of the slot. Now this is a tall, thin slot in tool steel. So that can be a bit of a challenging feature because the end mill is thin and thus is going to deflect a lot. So a good way to do a feature like this, I've been shown, is to plunge it rather than side milling it like you might be inclined to do. So do a series of plunge cuts down the length of the slot, translating over a little less than the diameter of the end mill with each one. If you tried to side mill a feature like this, you'd have to do a lot of really light cuts because you'd be battling deflection on the end mill, and you'd be getting chatter as well because of the toughness of the material and again how thin this cutter is. So plunging to get rid of the bulk of the material prevents all of those issues. And then once you've plunged your way down the length of the slot, you can come back in, side milling just the little bit of material that remains, basically where all the little curves of the holes meet up. And you want to make sure to do this with an end mill that's smaller than the final slot that you want, because you're not going to get a good finish on the sides of the slot doing that. I do some deburring there and check it with a gauge block to see where I'm at dimensionally. and then I can come in and side mill it to final dimension. That'll dramatically improve the finish on the sides of the slot. Final check with the gauge block here, and that is looking good. That is certainly on dimension. This is not a critical dimension, but again, it's good practice to, try to do things accurately whenever you can. Next up, I've got 3 parts that need to come out of this flat bar stock here that comes in the kit, 2 tiny little brackets, and then the pump handle itself. I'll start by squaring up the end here, and I'm going to do a little bit of kind of mass production here on these little brackets. The trick with them is that they're small, but the holes in them are close to the edges, so I can't even use my thin parallels here. So here's how I'm going to work around that. After centering up and finding the end, I'm going to center drill that part, and you can see that I've got it sticking off the end of the parallel there. Then I'll center drill the other hole now so that it's accurately placed. Then I come back in and drill through on the end here that's sticking out past the end of the parallel, so I can go through without hitting the parallel. Then I slide the part forward to line up that dimple mark under the drill. Now, using a drill on a dimple mark for alignment here is not a super accurate way to find a punch mark on the spindle, but it's good to probably 5/1000ths, which is more than sufficient for these parts. And then I can drill that one through as well. So the spacing on those holes will be good, and the distance from the first hole to the end of the part is good. So now I use an odd leg divider to mark the far end of the part. Then I cut that off with a fret saw, a little bit proud of that line there. So all the features have been referenced from that one end of the part, so everything should be accurate. I'll set that aside for now. I did the second one the same way, and now I've got them both almost done, but they both still have one rough end. So now I can use a drill here to align the 2 parts on the same reference, and I can set that into the vise there, and I'm using the drill to align that hole with the edge of the vise there. That's important. Pull that drill out, and then I can just side mill those down to the scribe line to get them both to the same length and to an accurate length. But I'm not done with this setup yet. Now I can come back in with my chamfering mill because the drawing calls for a 1/32 chamfer on all 4 corners of these parts. So I can do the first corner on both parts in one setup like this. And then what I like about this setup is once that first chamfer is done, I can put the drill back in, flip both parts over, and clamp it down again aligning the drill with the edge of the vise jaws there, and then run the chamfer mill down again without moving any of the slides on the machine, and those second 2 chamfers will be identical. And then I can do the exact same thing on the other end of both of these parts. You might think these parts should be end rounded, but I think they're not because the hole is so large in them, there really isn't enough material there to do a full end rounding on that. So 4 little chamfers looks nice. And then the pump handle was done the same way. I didn't show you that because it was just more of the same. Next up is an interesting challenge. The kit comes with these 3 steel rivets, and they need tiny little cross holes drilled in the ends of them. Rivets are difficult to fixture, so I'm going to make a fixture for the purpose. I've got a little block of aluminum here that I've squared up, and I'm going to put a hole roughly in the center of this that is a nice close fit on the rivet. So far so good. Then I'll set it up on end, and I'll cut through with the slitting saw roughly on center on that hole. I just eyeballed that. It doesn't have to be perfect. I'm cutting through the hole and then past the hole into the back of the block a ways as well, so that the resulting structure will be flexible and clamp reasonably parallel, considering it's got a single pivot point there. It's going to clamp kind of like a 5C collet would. And now I can slide the rivet in there, and I can clamp down on that with the vise, and it's going to squeeze the rivet into place and hold it securely. And then because this block has been squared up on all 6 sides, this fixture is repeatable there. I've aligned it with the front edge of the fixed jaw, so now I can edge find on the center line and the end, and all 3 rivets can be done in this same setup. I won't have to redo any edge finding or anything. So I put a little dimple in the top just because we're drilling onto a convex surface here, and the drill would wander off, and then I can drill through with the tiny drill, and presto, 1 tiny cross hole. Then I fish out that rivet and put the next one in, and once again align the front of my little block there with the front of the vise, and I don't have to adjust or measure anything else. I can just center drill and drill the second rivet all the way through, and it's going to end up in the same place. So it didn't take long to make that little fixture, and because I was making multiple parts, it was absolutely worth doing that. Next up is just a little threaded plug that goes in the top of the valve body. It's made from hex bar stock and really not very exciting. It's just turned down and some threads put on it, chamfers, parted off, Yahtzee, yada yada. Finally, I need plumbing fixtures. No model engineering project is complete without having to make a bunch of plumbing at the end. I start by drilling through with a small drill, then drilling up to a shoulder with a square ground drill, and then I thread that and part it off, and that is a pipe union nut. Next I make the matching cone by carving out the base with a grooving tool, and then I drill that through, and then I put a chamfer on that with a threading tool, and then part that off, and the final component is a simple threaded pipe. I needed 4 of those for this whole setup. Over on the boiler I've got this blanking plug here, which was intended for a feed pump someday, and well, someday is today. So I'll take some rough measurements here to get a sense of how much piping I'm going to need to get down to the pump there, which will someday be mounted on a base in a steam plant next to the boiler. So I cut that length from this tubing here, which I thought was copper tubing, but you'll see later that it turns out not to be. So I've got my union cones there and the pipe, which get soaked in pickling acid for 5 minutes. Everything needs to be clean and rinsed off so that I can silver solder these cones to the ends of the pipe here. Put some flux on there, and then I slide the union cone on the end of that pipe, and then I silver solder that in place. This is a very easy silver soldering job. This is quite a bit too much torch. I'm holding it far away and trying not to overheat things because these are pretty small parts. After the first end is done, then you can slide the union nuts on, and it's very important not to forget to do that because these are captive on there forever. That's how this style of plumbing fitting works. So once those 2 nuts are slid on there, then you can silver solder the other union cone on there. And yes, you will sometimes forget to put those nuts on first. I've done it. Everybody does it. Then when I went to clean up those fittings, funny thing happened. All the copper came off of my copper tubing. Yeah, it turns out this isn't copper. It's actually cupro-nickel brake line. So once I realized that, then I just polished all the copper off of it just to make it consistent. So it shouldn't rust because it's a nickel alloy, but not exactly the traditional copper look I was going for. Well, now I know why that copper tubing was so cheap. But the pipe looks good and the joints are good, so I'll bust out the tubing bender now and make some bends here to get the pipe down from that fitting to where I want the boiler feed pump to sit. Once again, eventually all these components will be bolted to a base and built into a steam plant. So for now I'm just estimating where things are going to end up, and I think that will work just fine. Now I can assemble the pump, so the plug goes in the top of the valve body, the packing nut goes in with the O-ring around the piston there. That's moving really nicely. That's just like the packing nut around a piston or a valve on a steam engine, same thing. And then all the little rivets and bracketry go together to form the hinge mechanism of the pump handle there. And I've got some cotter pins that go in there that are super tiny. I'm not going to fold those over yet because this pump is going to come apart at least one more time. But now we've got enough parts that I want to see if this thing works. It certainly feels smooth, but does it shift water? The threaded female cones go in the end of the pump body there, and those will seat with the male union cones that have been soldered onto the pipes. So hopefully you can see how this style of pipe union works now. It's a very elegant form of junction used in steam plumbing. They seal extremely well, and you can take them apart as much as you need to. Okay, here goes. It took a little time to prime it, but after a few strokes, look at that. It's pumping water. Very exciting. This is really fun. This is the best part of model engineering, when you put all this work into something and then it actually functions. It's not just for looking at. I don't know how efficient it is, and it remains to be seen if it can pump water against boiler back pressure, which is the key, of course, to a feed pump. The boiler is going to be operating at 60 or 70 psi, let's say. The pump has to be able to force water in against that pressure. But it shifts water, so this is a great start. For the pressure test then, I brought in the boiler, and I'm going to pre-fill it with water because I don't want to have to fill the whole thing with the pump. You can see the water level rising here. And what I'm going to do is I'm going to fill this boiler all the way up, and then I'm going to try to build pressure with the hand pump. Effectively, I'm doing a hydrostatic test here, if you like. So once water is coming out of the top valve there, I can close that up. And now, if the pump can build pressure in the boiler, then I know it'll be able to pump water against boiler pressure. And boy, does it ever. Look at that thing climb. It's climbing like 20 pounds per square inch for each stroke of that pump, something like that. I pumped it all the way up to 90 pounds, which is 1.5 times working pressure on this boiler. And it started bleeding down immediately because I realized I'd left the safety valve on there. So I plugged that off and did another test. And once again, pumped its way up to 90, no problem. At this point, the water gauge started leaking, so I had a few little things to tweak here. This boiler hasn't been hydro-tested since the move, so this was a good thing to do anyway. It was due for a test. So I got all those little leaks sorted out, and I'm happy to say this pump is performing extremely well. Very happy with that. Okay, but now we need a water tank. This thing is just stunning. The entire outer shell is seamless. You can't even really tell how it was made. The legs thread on with these studs that are made from set screws, which is very clever. There's no seams visible anywhere at all on the outside. I can't stress that enough. If you showed this to me, I could not tell you how it was made. There's a little bit of signs of manufacture on the inside. You can see there's what looks like a brazing or a TIG welded joint in the inside there, and there's a separate base plate, as you can see. The lid is made from 2 sheet metal formed pieces held together with the turned knob. Sits on there very nice with a decorative lip. A truly skilled fabricator is something akin to witchcraft in what they do, and that's what Ron's channel is to me, and that's why I love watching him work. He makes these things that, to look at the finished product, I can't even tell how it was made or how I would even begin. And it's just a joy to see all the steps that he goes through, and he really makes it look easy, and that's the mark of a master. I've got a few little clips here, but you definitely want to check out the full video on how he made this tank, linked below. Now I just need to make one more pipe to connect this tank to my pump. And yes, you will sometimes forget to put those nuts on first. I've done it. Everybody does it. Like I said, sometimes I forget to put that nut on there until after the cone is soldered in place. Yep. I was so annoyed at myself that I went inside and had a nap and came back out, cut the cone off, and soldered on a new one, and did it again. Yep. So I cut it off a third time and soldered a new one on and finally remembered the nut. And then I made an elbow fitting for that tank, and that went just fine. I hooked up the tank to my pump. These pipes are fairly temporary because I don't know where things are going to go in the eventual steam plant here, so I'll end up remaking them anyway. But I'll get the tank full of water here, and let's give it a go. I started by pumping the tank full. Now it's currently empty. I emptied it after the last test, so I'm pumping it full by hand just to see what that would be like. You can do it. It's not a lot of fun, but I did my time on that, and I did fill this thing entirely by hand pumping. And then once again, I closed that up and did kind of an impromptu pressure test here. I'm not going to pump it all the way up to 90 because the safety valve is once again back in place, but I pumped it up to about 50, which is about where the safety valve goes off, and once again, it held that just fine. You can see I've also got a check valve on the boiler there between the pump and the boiler. You got to have check valves on any inputs to the boiler, and that's just a standard PM Research commercial unit there, and it's working great. This is the most basic form of feed water system, simply pumping fresh water into the boiler. You can do many more advanced things. You can, for example, have a feed water heater, which plumbs the feed water through some part of the boiler to preheat it so it doesn't lower the pressure in the boiler quite as much. You can also capture the steam output from the cylinder, condense the oil out of it, and put that water back into your water tank to recover much of your water, and so on. But this is a great start, and it'll help this boiler operate for long periods. Thank you very much for watching. Thanks especially to Ron Covell for this amazing collaboration and that beautiful, beautiful water tank. And thanks to my patrons for making all of this content possible. And I'll see you next time.